Alright, so yesterday we talked about exponential growth. Today we are going to be talking about exponential decay. So lots of very similar things to what we had yesterday, except that our base of our exponential function is going to be between 0 and 1. So same idea with our learning goals. We want to be able to graph the exponential decay. We want to be able to identify the domain, range, and I'm also going to add and the asymptote of the exponential functions. And we want to be able to solve real-world application problems that use exponential decay. So, like yesterday, most of this is the same. Again, except the base here is going to be between 0 and 1. When we explored the exponential graphs, we saw that when this was a fraction, when your b was a fraction, that it decreased over time instead of increasing. So it approaches the asymptote as we go to the right instead of the asymptote being on the left side. So a is your constant, it can't be 0 again. Our y-intercept is going to be 0a, that's going to be our starting point for the graph, unless of course we have the shifts. If we have h values and k values, we will shift that starting point accordingly. Your asymptote is going to be at y equals k, so whenever you have a k value, that's going to be your asymptote. If you don't, the asymptote's going to be y equals 0. Domain still is going to be all reals for all of these. The range is going to vary depending on which value of a you have. So if you have a positive a, it's going to be all reals greater than the asymptote. If you have a negative a, it's going to be all reals less than the asymptote. So let's look at one of these to begin. We've got 4 times 2/3 to the x and then minus 1. So of our various values here, my a value is 4, which means that I would start my graph at 0, 4, except that my k value is -1. So since k is -1, 4 minus 1 is 3. So this one is going to have a y-intercept at 0, 3. So here is my starting point. There is my value there. Then I need to get a few more points just to have some additional points. I know where my asymptote should be because my asymptote should be at the k value. So my asymptote I can go ahead and draw in. I know that it should be y equals -1. So I'm going to write that down here. My asymptote is y equals -1. So I've already plugged in 0 for x, so now I'm going to try plugging in -1 for x. So if x is -1, that gives me 4 times 2/3 to the -1st. Well, -1st power is going to flip that fraction, so that's going to be 4 times 3/2 and then -1. 4 times 3/2, the 2 and the 4 cancel, this becomes a 2. So 2 times 3 is 6, minus 1 is 5. So at -1, the value is going to be 5. So right up here. At -2, again, I'm flipping it and then squaring it. So 4 times 3/2 squared minus 1. So 3/2 squared is 9/4. 4 times 9/4 is just 9, and 9 minus 1 is 8. So my y value there would be 8. So here's 5, 6, 7, 8. So that's pretty good on that side. Let's get something over on this side. So when x is 1, then I've got 4 times 2/3 minus 1. 4 times 2/3 is 8/3, And if I take away 1, that's taking away 3 over 3, so I get 5/3. 5/3 is like 1 and 2/3. So 1 and 2/3 would be about right here. So we can continue to get some more points if we want, but we should be able to see with just those points what the general shape should look like. We know it's exponential decay, so we know it's going to continue to approach but never cross that asymptote. So my asymptote was y equals -1. My domain is going to be all reals because my x's go on forever both ways. My range, in this case, it always goes with my k value, so it's -1, and my values are bigger. So it's going to be all reals greater than -1. So there are my answers there. All right, let's look at the next one. 2 times 3 to the negative x. So first thing I do, I see that my a value is 4. And I do not have an h or a k value, so that means I'm not going to have any shifting there. So that means my starting point is going to be at 0, 2, because I don't have any shifting. I do not have a k value, so that means k equals 0, which means that's where my asymptote is going to be. So there's my asymptote. If I make my chart, I already know that when x is 0, that y is 2. When x is 1, then I've got 3 to the negative first power times 2. 3 to the negative first is 1/3, so times 2 is 2/3. So I've got 1 2/3, so already pretty small. If I go up to 2, 3 to the negative second is 1/9, so this gives me 2/9. So again, very, very small. We're already very close to 0. At -1, that'd be minus -1 becomes +1, so 2 times 3 to the first would be 6. So -1 would have a value of 6. -2, we can plug it in, but it's going to be too big to fit on our graph because that's going to give me 3 to the second, which is 9, times 2, which is 18. So here's our graph, approaching that x-axis but never reaching it. The domain, again, x's go forever both ways. That's all reals. My range, they're bigger than the asymptote, so all reals greater than my asymptote, which is 0. And my asymptote, we already said, is the x-axis, or y equals 0. So there are our answers. All right, C. Here we have an a value of -5, which means that my starting point originally would be at 0, -5, but I do have some shifting here. I have this -2, which means right 2. So instead of 0, -5, my starting point is going to be at 2, -5. So I graph that. Notice that my k again is 0. H is 2, but k is 0, which means that again my asymptote is going to be here on this axis. Now, the reason it's down here is because the a is negative. Remember, when the a is negative, it flips, it reflects over the axis. So we know we're going to be looking at it essentially upside down. So I've already got when x equals 2, y is -5, so let's plug in 1. When x is 1, I've got 1/2 to the 1 minus 2, which is -1. So -5 times 1/2 to the negative first power. 1/2 to the negative first is just 2. So -5 times 2 gives me -10. So 2, 4, 6, 8, 10. It's the last spot on my graph. It does fit. Obviously 0 is not going to fit. Anything over here is going to be way too small. I mean, it's on there, but it's too small to list. So I'm going to get another point here when x is 3. So negative 5 times 1/2 to the 3 minus 2. 3 minus 2 is 1. So negative 5 times 1/2 is negative 5 over 2, which is negative 2.5. So 3, negative 2.5. At 4, I've got negative 5 times 1/2 squared. 1/2 squared is 1/4. So this is negative 5 over 4, which is negative 1 1/4. So right here. So that should be enough to see our shape. It approaches but doesn't touch our asymptote. And there is our graph. All right, the last one I'd like for you to pause and try yourself to see how well you understand this. Again, I want you doing this by hand. It doesn't help if you're just looking at the table and plotting points. We should all be able to do that by now. So try to go through with the reasoning. Where should your starting point be? What points do you pick? So pause it and then come back once you've got it graphed to check your answer. All right, so my A value here is 5. So that means I would start at 0, 5, but I look at my shifting to adjust that. I don't have an H, but I do have a K. So that means it's going to shift up 2. So instead of 0, 5, it's going to be at 0, 7. So 1, 2, 3, 4, 5, 6, 7. This is my starting point. I know my asymptote is going to be at positive 2 because that's the K value, so I can go ahead and draw that in. Then make a chart to get some other points. So I already know what 0 is, so I'm going to try 1. So 5 times 1/3 to the first is 5/3 plus 2. So when we add 2, we're adding another 6/3. So 5/3 plus 6/3 is 11 over 3. So 11 over 3, let's see, is 3 2/3. So 1, 2, 3, almost up to 4. So there's that point. And let's pick one more on that side. So when x is 2, so 1/3 squared is 1 over 9. So that gives me 5 over 9 plus 2. So 2 is 18 over 9. So we've essentially got 2 5/9, so almost 2.5. It's a little more than 2.5. So again, very small here. And there's my point. Let's see what happens when x is negative 1. So that'd give me 5 times positive 3, which would be 15 plus 2, which is 17. So that's off the graph. The only thing I can fit on here are 3 points. We usually try to get 4, but here we can only fit 3. So there is my graph. My domain is all real numbers as usual. My range is all real numbers greater than 2 because they're above the asymptote. And as previously stated, my asymptote is y equals 2. All right, so hopefully we're good at graphing and we can now meet the first 2 learning goals here. So last one is to be able to solve real-world problems. So here's our exponential decay model that we're going to use for the real-world problems. Very similar to the original exponential growth, not the interest one, but the only difference between the formula is that this has a minus instead of a plus because it's going to be getting smaller over time. So we're looking at things that get smaller over time and things that decompose would be one thing. So here we have a sample of iodine 131, and after t days, this equation, 50 times 0.92 to the t, is how much is going to be left. So everything stands for the same thing. Essentially, A is still what you started with, how much you started with. T is still time. R is still the percent decrease. And 1 minus R is our decay factor. instead of growth factor since we're decaying over time. So here, what's the initial amount of the substance? So that would be A. So I look at my formula and I see my A was 50. So it says amount in grams, so 50 grams is going to be my initial amount. What is the daily percent decrease? Percent decrease is R. It wants to know R. Well, what I have here, this 0.92, that's the 1 minus R. So if 1 minus R is 0.92, subtract 1, that means negative R equals negative 0.8. So R is 0.08. And again, it said percent decrease. So that would be 8% would be the daily percent decrease. How many grams of the sample are left after 3 days? So that just means plug in 3. So 50 times 0.92 to the third power would be our work. Then we can plug that into our calculator and hopefully come up with 38.9 grams. Again, don't just take my word for it. Make sure that you can actually plug this in and get the right answer, because that will allow me to help you if you're having calculator problems. All right, example 3. A new car costs $23,000. The value decreases 15% each year. Write an exponential decay model for the car's value. Remember that when it says model, that means T stays a variable. No matter what, if it says model, that T should stay a variable, time. So, starting cost was $23,000, so that's going to be my initial amount. Then I've got 1 minus, then the percent decrease is 15%, so as a decimal, that'd be 0.15 to the T. So, if I go ahead and simplify that, 1 minus 0.15 is 0.85. So $23,000 times 0.85 to the T is going to be my model that I could use. So now it wants me to use that model to find how much it has depreciated after 3 years. So now I can use my calculator to just plug that in. And again, try it yourself. Make sure you're getting the same answer. You should get $14,124 and about 88 cents. So after only 3 years, look at what has happened to the price. And decreasing by 15% means that it's worth 85% of what it was the year before. So you can see how quickly it goes down. Estimate when, so it's trying to find the year, the car will have a value of $9,000. So this is like working backwards. We have what it's supposed to equal. What we don't have is our T value. So here, we would divide by 23,000. And that gives us 0.3913 about equals 0.85 to the T. Now, later this chapter, we're going to learn a method for actually solving this exactly. But for right now, we're basically going to guess and check and find when that car is going to have that value. So we already know what it looks like after 3 years. So we know it's going to be more than 3. So looking at the difference between 14,000 and 9,000, I would probably start at 5 just because 4 probably isn't a big enough difference between those two in order to be able to come up with something close to the value here. So I'm going to try starting at 5. So I'm going to take 0.85, and I'm just going to show my work over here to the 5th power and see what I get. And I think you should get about 0.444. So not quite low enough. Let's try and see what we get when we do the 6th power. So in your calculator, put 0.85 to the 6th, and you should get 0.377. So we're after 0.3913. So this is too big, so it doesn't have the value quite after 5 years, but after 6 years, it's lower than that. Now, if you're doing this problem yourself, I would probably accept either of these answers. But it's somewhere between year 5 and 6. So I'm going to say about 5.5 years. Now again, you're estimating here. When we get to the point later in the chapter where we're not estimating, you'll be able to get an exact answer, you know, like 5.2. But for right now, we're just going to be estimating, so it's somewhere between year 5 and year 6. All right, that is it for today's lesson.